All right, welcome back. Our next topic in our triangle congruence unit is perpendicular bisectors. So just like that sounds, perpendicular means we have a 90-degree angle, and bisector means it is split in half. Whatever segment the perpendicular bisector is cutting through, it evenly splits in half. So if CD is perpendicular to AB, that's what this symbol means, and AD is congruent to BD, then the sides of the triangle, so side CA is congruent to side CB. And then the opposite of this is also true. If the two sides are congruent, then that means it has to form a 90-degree angle. It has to mean that if AC is congruent to CB, then segment CD is perpendicular to segment AB, which means AD is congruent to BD. So a couple of things to memorize with these theorems. So the types of problems you'll be, or algebra problems you'll be getting with perpendicular bisectors will be like what follows. So number one, let me zoom in a little bit. You can see here that not only do we have the 90-degree angle, but we also have the congruent base segments. So that was stated on number one, that if we have that 90-degree angle in the congruent segments, then the sides are also congruent. So you'll simply just set 7x plus 24 equal to 13x minus 48. A lot of stuff with perpendicular bisectors. We're going to look at angle bisectors next. We'll just be setting two different equations equal to each other. All right, now go ahead and solve. I'm going to add my 48 over here. Again, I like to keep things positive. So that's going to give me 72. And final answer is x equals 12. All right, moving right along, number two. And this is the second theorem at the top of your paper. So it's saying if the sides are congruent, then we know it forms a 90-degree angle, and then the base is split in half. So number two is showing us that the sides are congruent. So we know that we have a 90-degree angle here, and the base is split in half. So the 17x minus 3 is equal to 9x plus 13. So I'll go ahead and add over my 3 and subtract over my 9x. And divide by 8 so that x equals positive 2. Now these questions just say find the value of x, so that's all we have to do here. But on the next few, like number 3, it says find the value of rs. So then we'll have to find this segment here. So you'll just have to plug back in. It's the same type of problem. So again, looking back at your theorem that you have to memorize, if we have a 90-degree angle and the base is split in half here, then the sides are congruent. That's what number 1 is saying. So we just set the two sides equal to each other. I'm going to add over my 22, subtract over my 4x. So we get 3x equals 27 divided by 3, x equals positive 9. Now that's not our solution. This is the number one thing people miss in this unit. It's not difficult stuff, but you just have to read the question. So now we have to plug back in for rs. So you have 4 times 9 plus 5. So we get 36 plus 5 is 41, and that's your final answer. All right, same thing for number 4 and number 5. Number 5 is just asking you to find AB. So now you'll have to plug it into both. AB is the whole base. So once you set these equal and solve for x, plug x back in and add these together. But that's really it for perpendicular bisectors. I'll go ahead and upload the answer key for you for the rest of these, and put a little bit of practice online as well. So our next topic is angle bisectors. Very similar, except for instead of splitting a segment in half, you're splitting an angle in half. So our theorem states if AD, let me zoom in a little bit so you can see, if AD bisects the angle A or BAC, then AB is perpendicular to BD and AC is perpendicular to CD. That's where these 90-degree angles are formed. And so it has to tell you that AD is a bisector, or it has to have these little lines here that indicates it's bisected. Remember, bisected means it's split in half. So if angle BAD, this top angle, let's say it's 20 degrees, then angle CAD also has to be 20 degrees. The last thing this theorem tells us is that segment BD is congruent to segment DC. Those two top segments. Again, you have to have your angles and then your 90-degree boxes to know that. And then the opposite is true. If you have the boxes and BD is congruent to CD, then the angles down bottom are congruent. So that measure of angle BAD is congruent to the measure of angle CAD. So how did I write these? Follow the letters in order. BAD is this top angle here. CAD would be this angle here. So this is the same theorem, it's just written backwards on the second one. Alright, so the problems you'll see with this. Number 1, find the value of x. And this is like the very top theorem, how it's listed there. If we have the angle bisector, and we have our 90-degree angles up top, then this segment's congruent to this segment. So you're just setting them equal to each other. Again, that's pretty much what you're going to do for any perpendicular bisector or angle bisector problem. So you'll go ahead and set your 4x plus 30 equal to 9x minus 5. Again, I like to keep things, or try to keep things as positive as possible. So I'm going to subtract over my 4x and add over my 5 and get 35 equals 5x. Divide by 5, x equals 7. Check, is that what the question asked? Yep, so you're good there. Alright, number 2. Number 2 is the second theorem listed. If you have the boxes and the line segments up top are congruent, then this theorem states that it has to be an angle bisector. So it has to split this angle in half, meaning 5x minus 11 equals 8x minus 41. Remember, I said if this one's 20, this one has to be 20 for an angle bisector. And then we will solve. So again, I'm going to keep things, well, let's see, can I keep things positive? Not, oh, yes I can. Okay, I'm going to subtract over my 5x, and then I'm going to add over my 41, positive 30. Divide by 3, x equals positive 10, and that's your final answer. It doesn't tell you to plug back in. Nothing's really labeled, so we don't have any letters here. Alright, let's look at number 3. So this one is same idea as number 1. You set these two segments equal to each other and solve for x, and then you're just going to plug it back in to find AD. Let's look at number 4. So number 4 is, again, just like the theorem states up top, if we have our 90-degree angles and the segments are congruent, then it's an angle bisector. So this angle is equal to this one. So you just set your little expressions equal to each other and solve. Very straightforward algebra. Alright, I'm going to add over my 32, subtract over my 3x, and divide by 5. X equals 7. Oops, that's not the final answer. So now we have to plug back in. This is where people have a hard time reading this. Find measure of angle XWZ. So looking at your picture, you want to go in order and trace it. XWZ. So that's this angle on the left. Technically, it wouldn't really matter if you plugged it in this one because they have to be the same. But some problems will ask you for angle XWY. That would be the whole angle. That's when you would have to plug it in both and add them together. Or plug it in one and just multiply by 2, and that's your final answer. But this problem just wants us to find one of the angles, the angle on the left. That's XWZ. Trace it. That letter in the middle should help you. So when we plug it in, 8 times 7 minus 32. So we're going to get 56 minus 32. Final answer is 24 for number 4. Just be careful. I know some people will stop at x equals 7 when really the question asked you to plug it back in. Alright, the rest of the worksheet is the exact same. The only one that is a little different is number 5, because they want you to find the measure of angle FGH of the whole thing. So we still have our 90-degree angles and our segments that are congruent, so you're still going to set these equal to each other. Solve for x equals positive 19, and then I'm going to plug this in for one of them. Doesn't matter which one, because I want the whole angle here for this one. FGH, that's the entire angle this time. Unlike this one, they only wanted half. Okay, so we're going to get 19 times 2 plus 20, so just one of the angles is 58. And then I'm going to multiply this by 2 because they want the whole thing. So your final answer is 116. Alright, that's your angle bisector and perpendicular bisectors. I will post practice with solutions, and I'll post the filled in answer key for this. Thank you guys.